My name is Mazen Awad. I'm VP of Sales at Heat Pipe Technology. I'd like to thank you all for joining us today. We'll be covering today the two main products in the world of heat pipes that are typically used in HVAC, the wraparound heat pipe, or otherwise known as energy recovery in series. We'll introduce you to the next generation. It's already in Select Plus and it's selectable. We also will share with you another approach which has been around for a while but not quite selectable yet, but it lends itself more to large systems and controllable heat pipes. When it's done, we'll move on to heat pipe heat recovery, pushing the envelope of the latest changes and developments, advances in this field from our laboratories, and split passive series, which is becoming extremely popular for class 4 air and higher, and for applications where side-by-side cannot be done. Just a reminder that all our products are ETL listed to UL standard as well as Canadian standard that are applicable in this area, and our energy recovery heat pipes are also AHR certified. Remind everybody that Select Plus is a powerful tool out there. It's on the cloud. All you need is get a username and a password. You can do performance, psychrometrics, bin analysis, drawings. I believe it's the most powerful tool in the world of heat pipes out there. So if you don't have a username, please go to our website, click where it says Select Plus, and within hours you should have your username and password. Panoramic view of our laboratory. Pride and joy. A lot of stuff taking place here 24/7 for the past several years to get you all the advances and the developments that we will be sharing with you today, and the stuff that we've been selling the past few years. This is capable of testing sensible devices to the same conditions as AHRI laboratories, and it was vindicated when we got certified last year that our tests passed right away. Also can test all our products, including the 240-inch long heat pipe. So more and more to come out of those laboratories. Rest assured, what you're getting out of HPT has been tested, not been scaled up, not been extrapolated. You're getting the real thing. Starting with wraparound heat pipes. They were introduced by Heat Pipe Technology back in 1984, where the first wraparound patent was granted. At the request of the engineering community, early 1990s, we started adding valves to individual circuits, and the birth, that led to the birth of controllable heat pipes that controlled basically how the heat pipes to go from 0 to 100%. At heat wave conditions, when you don't want so much reheat, you start turning off those circuits, which are typically done in stages. Little changes taken place since then until earlier last month when HPT introduced what we call second generation wraparound heat pipes. We'll share with you those in the next slide. Basically, this is what we call second generation. It's a tilted heat pipe. If you note, there is a little tapering of the flange. The angle theta refers to it. And this gives us about 10 to 20% better performance. The tapering indicates that the tubes are slanted towards the front of the heat pipe. In the world of thermosiphon heat pipes, a little tilt goes a long way, and you'll see this proliferate throughout this presentation and other products as well. One other recent development is we've increased the maximum height per section from 60 inches to 75 inches, allowing more heat transfer per cross-sectional area, less flanges, better performance, and less static. Also increased the maximum overall height from 150 to 225 inches, allowing more CFM. So basically you can get with this 75,000 CFMs or higher even per system. 3 sections you can see. When you looking at large system, you start separating them into 75-inch sections. We can go up to 3 sections high. Once again, if you have any questions on anything that I'm saying out here, please type it in, and hopefully we will get to it. If not later, it could be direct through this presentation, throughout this presentation. One of the caveats here, this particular product, because of the slope, it does not lend itself to controllable heat pipes, but the next product that we'll share with you can fill that gap as well. So unfortunately, with controllables, they're not going to take advantage of that increase in performance. This is selectable in Select Plus under tilted. The standard is still there, and you can do all the controls with it. Flange dimensions will vary, but kind of that's a engineering detail, not for today's presentation. Take a look at performance comparisons between the standard and the slanted or tilted. We've selected the 3-row DHP, as in dehumidifier heat pipe, 100% outside air, 15,000 and change CFM, the usual 500 feet per minute. On a design day, 95 in, 52 out, here's what we got. Supply temp, 65.1 for the standard, and 2.1 degrees higher, or 2 degrees higher for the tilted. That is about, that's a 15% increase from the standard product. In the world of heat pipes, that's pretty significant. It really takes a lot of effort to get heat pipes to increase by 15% without adding more rows or fins. Some of you may have seen this at ASHRAE. It was part of our display at the booth. For the benefit of those who have not seen heat pipes, and maybe some of you are new to HPT, this is one of our most popular products. This is what we call the U-frame, as in the HPU. Ships mainly to manufacturers. They receive them, install them either in one section, 2 or 3, depending on the size of the heat pipe. They can drop it from top or from the side. The other 2 approaches, or other 2 installations, are at HPT, where it's not a U-frame. So some reps have made mistakes in the past, thinking, there's a U-frame, install it at HPT. No, installation is a little different. The end result is the same, but you don't have a lot of sheet metal that is usually part of the U-frame. Also, site retrofits, it basically, you got the pre-cool and the cooling coil, and the connecting tubing in between. You don't have the sheet metal in the back, which is really intended to protect the heat pipe, its structural integrity during transportation and the installation process. What we call the other approach, it is designed to reduce the number of circuits, consequently valves, so you don't have so many valves to control wraparound heat pipes. This particular product has been around for a while, but a lot of changes have taken place lately, and hopefully it will be selectable in Select Plus in the coming months as well. What you're looking at here is the pre-cool, where there's coming in, and the reheat on the other side. The tubes are vertical, fins would be horizontal. Vertical tubes allow us to construct headers at the very top and the bottom, and each header has a tube going from one side of the heat pump pre-cool to the reheat. The upper pipe is the vapor line, and the lower one is the liquid line. You see in the liquid line, there's a valve, and this valve will help control the flow of refrigerant, consequently the performance of the heat pipe. There are some considerations for this product. Performance is about average, lower than our standard, and we'll show you another iteration of this product where performance is actually quite enhanced. Because of the fins being horizontal, a continuous drain pan will be needed to capture condensate that tends to blow off from the pre-cooled heat pipe downstream in the direction of airflow. So as such, if an extended drain pan is not available, moisture eliminators may be needed. And because of the nature of this product, air profile is not quite uniform. air blenders will be needed downstream of the reheat heat pipe. The distance between pre-cool and reheat has been extended to about 60 feet. For wraparound heat pipes, almost never will be used, but if there should the need arise for a 60-foot span between pre-cool and reheat. The height per section is limited to 30 inches for this particular product. So larger systems may require multiple sections stacked. Could be 2, could be 3 sections, and each stack would have either 1 circuit or 2 circuits depending on the number of rows. 2-row system will have basically 1 vapor and 1 liquid line per section, and the stack will be about 30 inches high. How can we improve on the performance of this particular product? As we said earlier, angle inclination goes a long way. So if we elevate the reheat heat pipe by a quarter of the coil height, we start getting some serious performance enhancements. So you see here, the reheat heat pipe is sitting on a little platform, so it's about 25% higher, if you like, or offset higher than the pre-cool heat pipe. Same construction, a vapor line on top, liquid on the bottom, with a valve on the liquid line. Performance increased, and we'll show you the difference in performance between without an offset or level, the previous slides, and this particular one with an offset up to 25% of coil individual height. The same with the previous arrangement. A drain pan, continuous drain pan is needed to capture condensate as it'll tend to blow off from the pre-cool to the next coil downstream. Now the section height for this product or for this iteration, for this design, can go all the way to 75 inches. What does that mean? Fewer sections, so more area available for heat exchange and lower static pressure. And consequently, because of fewer sections, fewer circuits, fewer valves and controls, the price will be quite reasonable. The distance increases because of this slope from 60 to 120. You will never need that long for the pre-cool reheat, but it's there should it be needed. Now, the uniformity of the temperature across the face of the reheat is pretty good for this particular product, so no air blender is required. Now, if you don't have the continuous drain pan, a moisture eliminator would be needed as well. I didn't mention that earlier. Taking a look at performance comparisons, we've selected a 4-row, 100% outside air, 20,000 CFMs. Dimensions as stated here, on a design day of 9 degrees in, 55 degrees out. Let's see what we get for the offset and for the non-offset product. The level DHPV or dehumidifier heat pipe, the V is vertical, the temperature leaving 65.5, and the number of sections are 3 because of the limitations of the height with the level. Effectiveness is 30%. It's slightly under our standard wraparound heat pipe, which we alluded to earlier. As we create this offset, in this particular case 18 inches, we go from 65.5 to 67.5, significantly here with one section and with an effectiveness of 35.6%. That's a 19% increase, a pretty significant increase. Any questions so far? We good? Okay. John is signaling that we're good. So that pretty much wraps up our wraparound part of this presentation. We will be moving on to the energy recovery heat pipes, otherwise known in our nomenclature as HRMs, as heat recovery modules. Those have been around for a long time, even before HPT. HPT has been around since 1982. Some of those have been around even longer. I'm aware of some recovery heat pipes being available as early as 75 or so. Early 90s, HPT introduced heat recovery heat pipes that did not need tilting to operate, and still have this product, don't need to tilt it. However, as we said earlier, a little tilt goes a long way with heat pipes. Some of the products have that little tilt, permanent tilt, to enhance their performance in favor of a particular season. So, with this product, we have 4 configurations of design. At the popular side-by-side level, when you have equal summer-winter recovery, we have the permanent sloped for summer or winter, which we call it optimized, our HRMZ product. We have the over-under Airstreams, basically suitable for single-season recovery, and we have the split passive. And we'll talk about these separately in the coming slides. First one is what we call HRMH, as in horizontal. You're looking at 2-season recovery. Some geographies have enough or similar hours and BTUs as summer and winter. So this product is the way to go. In the center, you see that gap, and we'll talk about what developments are taking place through that gap. HRMO, the over-under, we mentioned earlier. The optimized for cooling, and then the optimized for heating. You'll notice the optimized cooling and heating at the bottom is sloped, basically installed level, and it will take care of business. Of course, you need to take into account where the arrows are going, where the hot areas and the cold areas is paramount, that this is done and taken into account. The side-by-side HRMH, again, when called for heating or cooling, is needed, or equal cooling or heating, summer, winter, this is the product that can do it. The circuits look like those to the lower right corner. So what's new with this product? The gap. And if you'd used this product before, the gap used to max out at about 8 inches. Now we can go all the way to 40 inches. That gap can be filled with polyurethane that expands and fills that gap, or in lesser contaminated environments or lower class airs, if you like, that gap can stay basically full of air. A little, if you like, contamination will take place. Our product under testing actually shows practically zero cross-contamination between airstreams. It is always advisable to fill that gap with polyurethane, and that's an adder that's available in our selection program. Maximum fin height had increased from 60 per section to about 75. Again, fewer sections, less cost, and more room for heat exchange. Overall fin height had increased all the way to 225 inches, allowing 75,000 CFMs and higher through the supply and through exhaust. Overall dimensions have not changed for this product. You'll see in the next couple of products that this dimension had increased quite a bit. So with this product, that's limited to about 200 inches combined. So if you have a gap of 40 inches, you have 160 inches left. If it's equal airstreams, then the 160 is split equally between supply and exhaust. So you have 80 by whatever the height is, and 80 by whatever where the height is. And the sweet spot for this particular product is 6-row, 500 feet per minute, 12 fins per inch. Moving on, and again, we'll see that slope appear here on this particular product. This is optimized for heating. Which is optimized for heating, for cooling, I apologize. Cooling or heating, HRMZ is used for both. This particular one we're showing is optimized for cooling. How do I know? The 95-degree outside air to the left, and the cool exhaust air is to the right of 75 degrees. This is doable with a little angle, a little slope that we apply to the tube length. The optimized for heating, As you can see on the left is cold outside air of 35 degrees, happens to be the higher end, and the warm end is the lower end of 70 degrees. The golden rule of thermosiphon heat pipes is the warm air is always on the lower end. Of course, it can work when it's level, but enhancements can take place, and we see here, and you will see as we show you the performance, that it does actually make a difference if you have a little angle. Moving on. Vertical heat pipes, we've taken those circuits and basically turned them vertically, so the fins would be horizontal. So the same rules apply to the horizontal fins that you've seen in the wraparound product. So this is more suited for single climates, way south where it's really only cooling recovery, and way north where it's mainly heating recovery, or in a process application whereby warm air escaping a building, where you're trying to capture the energy that's in it. This would be very suitable. This product had proved itself very useful in data centers, and quite a few systems were sold this year, last year, and previous years as well. You can put 6 rows, incorporate that in an air handler, and your energy saving can be as high as 56%, you'll see on the next slide. Now, this particular product, the overall height has increased from 200 to 140 inches. This is already incorporated in our selection program. Before, with a flag do, now you're able to do 240 inches. Of course, a gap extension applies to this product as well. It went from 8 to 40 inches. Caution again with that we said earlier, so extended drain pans will be needed in condensing air streams. Any questions? Please type them up. If we're able to answer during this session, of course we will. Otherwise, we can leave them till after the presentation individually, or I can announce them and answer them at the end of this presentation. Okay, how do these things compare, those configurations compare? On the left is the effectiveness chart, which is basically, some of you may not be familiar, is what a device does to the theoretical maximum recovery, as it applies to sensible and as it applies to latent. On the lower line, it's in metric and in inches, the individual length of each airstream. So HRMO takes the cake on this particular one, about 55% recovery. It does that because it's basically utilizing gravity. It's a single season recovery. HRMZ as an optimized during the on season, it's in the lower 50s, 52 for 3, and we'll actually show you a real example in a minute. HRMX, the 2 season, that does similar performance for summer and winter. In the on season, or the season that matters the most, we do pretty good. And actually, as a bonus, you still do okay in the off season. And for shorter heat pipes, it actually starts a little higher than 40%, but as the heat pipes get longer, to almost to the max, it drops to about 20%. So since you're shooting for a particular season, the other season may not have too many BTUs, but even then, you're doing fairly good recovery in the off season. Let's look at an example of a 6-row, as we said earlier, which is the sweet spot for energy recovery heat pipes. We're looking at 100% outside air, conditions for 10,500 CFM, the usual 500 feet per minute, design winter day of 30 degrees, and usual exhaust of 70 degrees, 50% RH. The level, supply temp 48, and it increases and increases. It's the useful, obviously, side of the heat exchanger. We don't really care what's happening on the exhaust side, but should be very similar to the pre-cool, provided condensation is not taking place. What's important here is effectiveness. This is basically translated into the temperatures on the left. The HR match level is 45.3%. certified performance, as we said earlier. The tilted, which is optimized for the season with the most BTUs to recover, jumps to 55.6, and we do even better with the HRMO over-under, which is kind of 90 degrees from horizontal. Improvement percentage-wise from HRMH to tilted is 22%, and to the upright increases even better to 24%. Let's see how this translates as we take a particular city and see which works best for this particular city. This is New York, and we've selected a system of 75-degree exhaust summer, 70 winter, and outside conditions of bin data for New York City. This is the bin profile for New York, the usual build curve, where extremes a lot less, and you got the bulk of view temperatures are the milder ones, if one can call those mild ones. Okay, so how does that HR match compare to HRMZ and all that good stuff? In the two-season recovery, which is level, we actually do pretty good, a little over 800 million BTUs. But if you optimize it for the season with the most BTUs, obviously it's winter. In New York, you do even better. But if you optimize it for cooling, you don't do that well. So clearly for this city, optimized for heating is the way to go. And if you really want to do summer-winter recovery, you'll not be far off, but you'll be leaving about 40 million BTUs or so, basically to escape through the exhaust. Any questions so far? Good?
We have one question.
One question. Okay,
yeah, so it's should they monitor for refrigeration leakage?
Okay, good question. We get this asked all the time for this particular product, and some of our products, with higher circuit capacities, that tend to be the DHPV, the vertical tubes, and we'll be talking about the split passive shortly. We leave it to the design engineers to basically observe local codes and do the monitoring if required, if it exceeds a certain amount. But for the bulk of our products, circuits are numerous, including the product I've just shown you here, and HRM's heat recovery module and the standard wraparound heat pipe. The circuits are numerous, and the amount of refrigerant is not that huge. I mean, you're talking in terms of ounces, a pound or two max, without revealing too much about our charge here. So for some products, small, do not need other products, you may want to consult local codes and standard to make sure if an amount is exceeded, you may need to do some monitoring. So I hope that answers that question. Moving on. What happens if you combine energy recovery with wraparound heat pipes? A lot of good things happen, I say, and we'll show that to you in a minute. This is, let's say, a typical air handler. Air comes in, you capture some BTUs from the exhaust, pre-cool the air coming in, and then you feed that to a pre-cool heat pipe, cooling coil, and reheat heat pipe. Actually, surprisingly, the DHP performance doesn't take a huge hit in this particular example. Of course, one has to do the numbers for their geography and location, and our Slick Plus can help you with that. If you run into some difficulties, our engineers will be more than happy to help you make that decision. Of course, the premise here is you're looking for wraparound heat pipes to pre-cool and reheat, okay? And that's why you're including a wraparound heat pipe. Take a look at this particular example. If we do DHP only, as in wraparound heat pipes, we are saving 277 megawatt hours. Pretty extensive. HRM only, again, this particular facility, this particular example, 163 megawatt hours. Combining them, you're looking at 424 megawatts. So pretty substantial savings. Now, in some locales where mainly summer recovery, the DHP or wraparound heat pipe may be hit a little bit more. But again, you need to do the numbers for your particular facility to see which works best for you, the combination of the two, or one or the other. Let's hope the next one we get the animation going. I apologize, this should have been tested. Yeah, this is basically an HRM being installed with a bypass damper, flashing around it, close off, done deal. Moving on, take a little pause here, give you a chance to ask questions on the previous product as we move on to the very popular split passive product and all the new changes that have recently taken place. We good?
Can you give a general description of maintenance requirements?
The question is which product? Generally speaking, with heat pipes, you really don't have a lot of moving parts. If any, you've got the refrigerant flowing, from one side to the next. If you have valves on them, the valves are typically not really your typical solenoids that are on off 100 times a day. Those things are on, some mornings, off evenings, perhaps. So little maintenance is actually required if you happen to have valves in your systems. But most of the heat pipes that we put out there have or need little maintenance. Our IOM, if you've care, we could be more than happy to send that to you. You can actually take a look at what's required for those products. But generally, minimal maintenance is required. It's really the most important, I should mention, is keep those coils or the heat exchangers clean, put filtration ahead of them when it comes to energy recovery, ahead of the exhaust, and you'll have filtration ahead of your supply anyway. But just make sure, as design engineers and manufacturers, that you have filtration ahead of your exhaust side of the energy recovery heat pipe, being it the standard one-piece heat recovery module or the split passive, which we'll be talking about shortly. Any other questions? Good. Moving on. Split passive. We show you here a system that's supply and exhaust are on the same level, similar to our HRM etch, basically. This is a two-season recovery. Performance is average. You can get about 39% with 6 rows, 500 feet per minute. This is your typical system made up of 6 rows. Each 2 rows are headered into a vapor up top and a liquid header on the bottom. And most have valves on the bottom to regulate the performance of this product, should you want to tear it off during economizer mode or to prevent frosting under severe winter conditions. Similar to the vertical DHPV, as in wraparound heat pipes, the maximum section height in this case is 30 inches, but significant increase to the distance from supply to exhaust. It went from 40 to 60 as 20-foot increase. That gives the engineer even more flexibility to place the supply and exhaust apart, to work around obstacles in the design process. Considerations: the temperature profile across the supply side, very similar to the wraparound heat pipes, is not uniform. So you could have freestat trips and so on. To prevent that from happening, air blender is needed downstream of the supply side. So that is a requirement. In the past we mentioned it, but we believe that it needs to go on every system. Of course, if you care about your freestats not tripping. I'm sorry, I hit that button too many. Similar as the previous product, the wraparound heat pipes, extended drain pans will be needed on the downstream side of those heat exchangers, unless you have extended drain pans. So the extended drain pans or moisture eliminators would be required. How can we improve on this? You probably will guess by now. We include an offset, very similar to the wraparound heat pipe DHPV. The offset is, again, 25% of coil height all the way to 50%, but you start getting really, really good performance as your offset is 25%. Caveat here, this will only work in one season. It'll give you a little bit of performance during the off season, but it'll work in one season. This particular configuration you're looking at, in winter, the lower side would have to be your exhaust side. During summer recovery, the lower side will be your outside air, and the upper side will be your cooler 70, 75 degree air. With this, much better performance is attained. We'll show you the difference in performance between the offset and without offset. Section height, again, similar to the previous product, the HPV, it goes from 30 to 75 inches. What does that mean? More area for heat exchange, fewer sections, fewer circuits, better heat transfer, and actually better pricing. Significant increase here between supply and exhaust from 100 to 120 feet. Vertically speaking, that's roughly 10 stories high. So you can actually get this working anywhere from the basement level to the roof of a building. It'll be a single season, but you get the most out of that season. Will you need air blenders here? No, you do not. The temperature profile across supply side is fairly uniform, so no air blenders are required. However, you still need a moisture eliminator or an extended drain pan on the warm side or the lower side of this heat exchanger. Any questions before we move on? Chance to type it in. Any questions, John?
Right now I'm just shooting stuff.
Okay, very good. Okay, let's take a look at performance. What we seeing here is level performance, because this level, the maximum section height is 30 inches. So for this particular example, we will need 3 sections stacked. And what you're looking at are those orange, the pipes that go between the supply and exhaust, the vapor line up top, liquid line on the bottom, and so on. Effectiveness. This is one product that is sensitive to temperature differential, so it tends to vary summer, winter. So winter we have the larger delta T's, so effectiveness is 39% for 6 rows, 500 feet per minute. You could lower base velocity, and actually you can get a recovery or effectiveness to go a little bit higher. You can spray the exhaust side, the direct evap cooling, and enhance that as well. If we do an offset, we actually get away with fewer sections, but what that means, the air would be squeezed into a tighter area, so the face velocity increased a little bit, so static pressure is a little bit higher, so it might cost a little bit, but the improvement in performance will more than make up for this. Again, we're showing a 25% offset to get this increased performance. How do we do effectiveness-wise? Winter, 50%, so 39 to 50%. Summer, because it's off-season, it drops from 32 to 13%. But then again, your most BTUs are in winter, and that's a premise for doing this product. So you're not being hit. It may sound or look like a fairly big summer job, but again, if you don't have too many BTUs, you should not be concerned with that, and we'll show you that in next example. So this is kind of a bin profile to show you in winter. The blue graphs or bars are for those offset scenario, and the level is the red. See, most of your recovery is happening in winter in this particular example, and the level does better in the summer, but very far fewer hours during the summer. So let's take a bunch of cities here. If you're near one of those cities, you'll see which one works best for you. For Canadian friends, Montreal as an example of extreme cold, if you like. We are showing the profile on the left, and we summarize the conditions on the right. So if you do level, basically looking at 899 million BTUs, a lot more if it's offset. Basically, we're looking at roughly 26% increase if you go from level to the offset in favor of winter recovery. The other end of the continent, Seattle, fewer bins, same difference between level and offset, actually 26% better recovery in winter as well. Another city, New York, fewer bins, but more than Seattle, fairly meaningful difference, or about 23% if you optimize for winter heating. Des Moines, Iowa, another 23% difference in favor of optimized winter heating, and offset meaning in favor of winter recovery. Now representing the South, the great city of Baton Rouge, it's almost a toss-up. You can actually get by with or without an offset. There's about 4% difference in performance. Again, this is an animated slide showing how this product is installed. So on the side is your supply side, and 2 rows at a time go in. Exhaust on the left. It's either done on site or manufacturer's facilities, and the box is shipped, stored in place. The piping is done in place. HPT crew will travel to the site to witness a pressure test, vacuum, and charge. And the system will work, without any moving parts for years and years. Share this with you. A rep in Chicago had sent this to us, a recent project. Really neat. Looks like taken by a drone. On the right is your supply air handler. On the left is exhaust. I can tell by the number of pipes between supply and exhaust. This is a 4-row system. 2 tubes on top and 2 on the bottom. Top representing vapor, the bottom representing liquid. So, in summary, a little tilt goes a long way with wraparound heat pipes. We get about 10 to 20% performance, depending on the length of the tube. The other approach of controllable verticals work better than offset by up to 19%. The gap in the energy recovery heat pipes goes now from 8 to 40 inches. Certain HRMs, or heat recovery modules, can go now from 200 to 240 inches, specifically the optimized HRMZ and the over-under. And split passives, now you can extend the distance and from 40 to 60, if level, from 100 to 120 with an offset, and the performance with an offset increases by up to 35% for the season that you optimize for. So, finally, with heat pipe systems, you're actually getting actual performance, not extrapolated, and you're getting guaranteed results and HRI certified for most of our products. With this, I conclude my presentation, but do stay tuned for more innovations. Hopefully we'll have a similar webinar in the coming months with the latest developments coming out of our R&D and testing, which will be turned into useful products. We will give you, as we said earlier, it's 45 minutes past the hour. We have a few minutes for any questions that you may think of. John is indicating that we have some. Go ahead, please.
Yeah, one is what level MERV filter is recommended ahead of the intake on an HRM unit?
The same filtration that you use on a regular air handler. I would say the higher the MERV, the better, but if your air handler requires 30 or 60, that's what we should use. So nothing special. This is the heat exchanger that looks like a cooling coil, but behaves very differently.
Another question is, do you typically do retrofits of existing units to add recovery or include in new systems?
In all honesty, most of the recovery systems that we do tend to be plan and spec. But having said that, we have actually retrofitted a couple of facilities in Indiana recently that had wheels. Owners weren't happy about the maintenance required, and they were taken out, wheels taken out in favor of heat pipes. So retrofits are doable. It really depends on the configuration on the site. Now, you'd think split passives lend themselves to this. This is an old new product. I'm sure we're going to be doing some retrofits in the coming months and years. Any more questions?
Looks like we have one for split passive. What is the maximum coil width?
Maximum coil width, okay. Well, recently, actually, we're doing a fairly long system right now. So tell me, what are we doing for this recent project?
Talking about the length, we have maxed out at 155 inches. 155. We have gone larger, depending on the application.
Exactly. So start with 155 inches. And obviously, this product is, unfortunately, the split passive is not selectable. I'm assuming you're referring to splits, right?
Mm-hmm.
Okay. They're not selectable yet in Select Plus. Hopefully down the road they will be. As such, our engineers will do their best to accommodate, I guess, your request. But start with 150. If we need to go a little bit longer, that will depend on the geometry of that particular location and design. Any more? So while we're waiting for your questions, please do not forget to answer the survey. That's how we can improve. That's how we address future presentations that you may ask us to do. And John wants me to do a plug-in for him. You want to do that yourself and now make the announcement, John Elfie, Applications Engineer?
Yeah, so everyone, I'm going to be doing a webinar in 2 weeks from today. It's actually going to be on Select Plus, and it's going to cover some of the new updates that we have that Maz talked about. It's going to be the same time, 2 o'clock p.m., and I guess the date for that is going to be the 22nd of March. So I will send out an invite. If you guys want to join, please feel free to do so. You should see an invite actually later today for that webinar.
Thank you, John. Yeah, John does pretty well with his webinars, and if you really want to know, select all or learn how to select all those changes and the products we've shown you, except for the ones, unfortunately, that are not in the program. John is a master in the use and applications of heat pipes using Select Plus. Still have a few more minutes. We'll be happy to address your questions. If a question pops up, once this is over, you know how to reach us. Sales@heatpipe.com. We'll get it direct to me, and we will attempt to address questions or concerns. We'll give you guys a few minutes. Think of any questions. Okay, I guess no more questions, right? Anything coming in?
No more. Looks like.
Okay, well, at this point, we will wrap up. I want to thank you once again for your time. And for those of you who are looking for participation or certifications that you participate in this, please send an email to Heat Pipe Technology, sales@heatpipe.com. And we will be happy to send you a certificate of attendance that can be used for your local Board of Regulation, PE, or otherwise. Thank you once again, and we'll see you at a future webinar.